Okay, let's take a look at an example involving concavity here. So in a prior video we talked about how a function is concave up if its second derivative is positive, and a function is concave down if its second derivative is negative. So here it says identify the x values where f of x is concave down. So the function is 1 over 20 x to the fifth minus 2/3 x cubed plus 5. So we want to know, if we want to know where that function is concave down, we want to know where its second derivative, which is f double prime in this case, is negative. So in order to figure that out, we're going to make a second derivative sign chart. So first things first, I have to find the second derivative. So I'll take the derivative. So I'll bring the 5 down in front. It'll be 5/20ths, which we could simplify. We'll do that later, I think. Okay, subtract 1 from the exponent, minus, bring the 3 down in front. It'll cancel out the 3 in the bottom, leave us with 2x squared, and then just the derivative of 5 is 0. So I need to take the second derivative, so let's take another derivative here. Bring 4 down in front. When I multiply the 4 times the 5, it's going to be 20, so 20 over 20 will just be 1, so it'll just be x to the third minus, and then 4x when I take the derivative of that. Alright, so in order to make a sign chart, I need to see where the second derivative is equal to 0. So I'm going to do some factoring here. Let me start by factoring out x. Do that, I'll leave me with x squared minus 4 is equal to 0. I can factor this further into x times x minus 2 and x plus 2. So I have zeros at 0, negative 2, and positive 2. The negative 2 being from this one, positive 2 being from that one. Those are my zeros, so I'm going to take those and I'm going to put them on a second derivative sign chart. I'll label it f double prime, so I know I'm thinking second derivative. That's where I'm going to plug my test values in a moment. So on that chart I'll put negative 2, 0, and 2. Alright, so I need to test values in the intervals, first interval here and in between there and so forth. So I'm going to test it back in the second derivative, and I'll do it into the factored version right here. It'll just be easier for me. So let's say I test negative 3. I plug negative 3 back in, so it's going to be a negative here. If I plug negative 3 into this portion here, that'll be a negative 5, so that's negative. Plug negative 3 in here, that'll be another negative, so I have a negative times a negative times a negative will come out to be a negative. Okay? From negative 2 to 0, let's see, I plug negative 1 in. So that'll be a negative, that'll be a negative, that'll be a positive, so negative times positive will be positive. From 0 to 2, plug in 1, that'll be positive, that'll be negative, that'll be positive. So overall it will be negative. And let's say I plug in 3, positive, 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 so overall it will be positive. So that's my second derivative sign chart looks like. Now again, I was trying to find where this function is concave down. Well, the second derivative is negative from negative infinity till negative 2, and from 0 to 2. So the intervals would look like this, negative infinity to negative 2, and from 0 to 2. That is where this function is concave down. If I were asked where this function was concave up, I would have done all the same steps, except I would have just looked at my second derivative sign chart to see where the second derivative was positive.